Right, now we will go through the complex number operation. So let's say if you have two complex number in Cartesian form. Okay, and then you have two. The first one is Z1, which is equal to A plus BI, and then we have Z2, which is equal to C plus DI. Okay, let's say if you want to do addition of Z1 and Z2. Okay, Z1 plus with Z2, you have to just substitute the complex number form, which is A plus BI plus with C plus DI. This one easy. Okay, you just combine them. Okay, make sure the one that is the real part you plus together, which is A plus with C. And then the imaginary part, which is we have B and D here. So you just plus it together. B plus D, I. This one easy. Subtraction also similar. Okay. So let's say if you want to do Z1 minus with Z2. So by right, your Z1 is A plus BI minus with C plus DI. So by right here, you just maintain A plus BI. Oh, sorry, my writing is very bad right now. BI minus with C minus with DI. Remember to expand it properly with the sign. Okay, and then here, make sure you put the real part together and imaginary part together as well. So A minus with C plus with B minus with DI. So that is how you can do for subtraction lah. Now what if you have scalar multiplication? Okay, let's say if you want to do K multiply with Z1. Okay, this one also similar. You can just expand it. K multiply with Z1, which is A plus B. I have become KA plus with KB I. Okay, now we will proceed to the multiplication of Z1 and Z2. So that's if you have to multiply Z1 and multiply Z1 and Z2. Okay, you just substitute Z1 Z2 here. Z1 is A plus BI, Z2 is C plus DI. From here you just expand lah. A multiply with C, AC. A multiply with D, which is you're gonna get ADI. Okay, and then you expand B multiply with C, which is BCI. Then B multiply with BI multiply with DI, you're gonna get BDI square. Okay, now from here, if you see, right, we have I square there. So when you have I square, okay, you can change it. I square is actually equal to -1, right? So you change it to substitute -1 inside. You're gonna get AC plus with ADI plus BCI minus with BD. So from here, you combine the real part, which is AC minus with BD plus with AD plus with BC I. Okay, so this is how you can do for multiplication. Now we will go through multiply conjugate in case there is question where you have to multiply conjugate. Okay, which is, let's say Z1 multiply with conjugate Z1. So by right, conjugate is we change the sign of the imaginary part, right? So A plus BI multiply with A minus BI. Here you will get, if you see here, it is similar also A plus B with the term A minus B. We can change into A square minus B square. Then we do together also with this. So A square minus with BI square, where you're gonna get B square I square. Then I square you change to -1. Here you're gonna get A square plus B square. Okay, now we proceed to the next one where we have division. Okay, so for division of Z, which is Z1 divide with Z2, what you have to do is you copy first Z1 divide with Z2, but then when you want to solve this, you have to multiply with the conjugate of Z2. So Z2 divide with Z2, conjugate of Z2. So by right, let's say if Z1 you have A plus BI, divide with C plus DI, you have to multiply with conjugate of C plus DI. So C minus DI divide with C minus DI. Then you move until you solve the question lah. Okay, so we proceed to the exercise. Okay, so we go through question 2. They ask us to simplify 2 plus 5i plus with 3 minus 2i. Okay, so here easy je, you just expand this properly. You're gonna get 2 plus 5i plus with 3 minus with 2i, and then combine together the real part, which is 2 and 3. So 2 plus 3 plus with 5 minus with 2i here. Okay, so you will get 5 plus with 3i. So that's it for question A. Now we proceed to the next question. So the next question, we have negative 3 minus 2i minus 3 plus 8i. So here, easy for you to solve. You expand first, negative 3 minus with 8i, and then you combine the part where it is actually the real part and imaginary part. So negative 3 minus negative 3. Okay, so negative 3 minus negative 3, you're going to get negative 6. Negative 2i minus negative 8i, you're going to get negative 10i. So this is your final answer for this question. Okay, so we will go through the next question. Okay, so for this question, right, we actually can just expand. Okay, so we expand to multiply with 2 plus 3i multiply with 2 minus 3i. So if you see, right, this one, okay, it is actually similar. This is A, you imagine that this is B, this is A, this is B. So this is A plus B, A minus B. If we multiply them, we can get A square minus B square. So we can use this form, which is 2 square minus with 3i square. Here you're going to get 4 minus with 3 square I square. So 4 minus with 3 is actually equal, 3 square is 9, I square is negative 1. So you're going to get here 4 plus with 9, total is equal to 13. Okay, so this is another way to solve lah. Okay, because if you see here 2 and 3i is the similar component, just sign is different. Okay, I want to show you another example, which is question D. Okay, for this one, we can expand one by one lah. So 2 multiply with negative 2, you're going to get negative 4. 2 multiply with negative 3i, you're going to get negative 6i. And then you do the same also to the next term. 4i multiply with negative 2, you're going to get negative 8i. 4i multiply with negative 3i, you're going to get negative 12i square. So here I square is negative 1, right? So you substitute inside. Okay, negative 12, negative 1. And then here, negative 6i minus 8i, you're going to get equal to negative 14i. So this one plus 12. So negative 4 plus 12, you're going to get 8 minus with 14i. So this is the final answer for question D. Okay, now we proceed to the third question. Write down conjugate for each of the following complex number. Okay, so we have 2 plus I. So when we want to change to the conjugate, so you just change the sign for the imaginary part here, which is negative I. Also the same for 3 minus I. Minus you change to positive, so 3 plus with I. So the same with the previous one. The real part no need to change, so you just put negative 1 minus with I. Okay, also the same for question D. Negative 2 you maintain, then you change the sign for negative 5 to plus 5i. So that is how you do question 3 now, which is very simple. Okay, now I'll show you example question 4. Okay, now for question 4, they ask us to simplify 2 plus I divide with 3 minus I. If you see here, this is in the division form. So you have to use division operation lah. Okay, so this guy is your Z1, this guy is your Z2. Okay, so when you want to solve division, so Z1 divide with Z2, multiply with the conjugate of Z2 divide with conjugate of Z2. So here we have 2 plus I, you copy first, 3 minus I, multiply with, our Z2 is 3 minus I, right? So 3 plus I, you change it, 3 plus I. Here you're going to get, and then you combine, you'll get 2 plus I multiply with 3 plus I, divide with 3 minus I, multiply with 3 plus I. Okay, now what you can do is expand them lah. So 2 multiply with 3, you're going to get 6. 2 multiply with I, you're going to get 2I. And then you expand the next term. I multiply with 3, you're going to get 3I. I multiply with I, you're going to get I squared. Divide with, and if you see here, it is actually in the form of A minus B, the denominator, A plus B. So we can change it to A square minus B square. So 3 square minus with I square. So I square is equal to negative 1, right? So we substitute inside. 6 plus 2I plus 3I minus with 1. Okay, divide with 9 minus with minus 1. You're going to get 6 minus 1 equal to 5. Plus with 2I plus 3I is 5I. Divide with 10. So here you can factorize 5 outside, 1 plus I. Then divide with 10. Here you can divide 5 divide with 10. So you're going to get 1 plus I divide with 2, or you can factorize 2 outside, 1 over 2, 1 plus I. Like this. Okay, so that's it for the topic of complex operation.